we have learned was what is a firewall. So what is that we have learned? That a firewall is a device which could be a hardware or a software device which is used for implementing a security policy, and usually this is placed between a trusted network and an untrusted network. This is how your definition should be when you are talking about a firewall. So when you are answering anyone in the interview, this is how it has to be technical. So don't say a firewall is something which is protecting our network. That's a layman's answer. When you are in the interview, you have to answer with technical terminology. So you have to use this key words like trusted, untrusted, security policy. So these are the things which the interviewer would look into when he is expecting an answer. So quickly, a firewall is a software or a hardware device used for implementing a security policy. Usually a firewall is placed between a trusted network and an untrusted network. So what is a trusted network? A trusted network is your LAN, for example, and untrusted network is a internet which you do not have any control over. So that is how you define a firewall. Next, what else did we learn? What is the difference between a gateway and a firewall? See, basically a gateway is used for joining two networks together. A gateway is a device which is used for joining two networks together, that is network 1 and network 2, and it routes the IP packets from one network to another network. So this is what is a gateway. Now what is a firewall? Firewall is also doing the same job, that is one network to another network. It is routing the IP packets, but apart from routing, it is protecting the packets. It is protecting the packets or filtering by using filtering or whatever terms you use here in the firewall. It does an extra job of protecting the flow of traffic. It examines the traffic from one network to another network, which your gateway would not do. So how do you put it? Finally, a gateway joins two networks together, and a network firewall will protect a network against any unauthorized incoming or outgoing access. So network firewalls could be, as I told you, it could be a software or a hardware. This is what we have learned. And then which layers do these firewalls work? Which layers do the firewall work? The firewall would work at layer 3, layer 4, and then at layer 7. Okay, so firewalls will work at layer 3, that is filtering the IP packets by source or destination. Layer 4, port numbers, and layer 7, they are also inspecting the type of application data which is going on from or through the firewall. Now we have also learned about something called as statefulness. What is a stateful? What is a stateful firewall? So a stateful firewall is aware of the connection. So whenever a connection is made from a LAN to the internet, for example, a stateful firewall would examine the traffic which is going on. Let's say you are making a TCP connection from the LAN towards the internet, and so my firewall would remember the session, and then when the return traffic is coming back for that session from the internet towards the LAN, so it would tend to allow it because it remembers that the connection has been initiated from the LAN towards the internet. So this is called as stateful firewall. So how do we put it in a simple way? A stateful firewall is aware of the connections. Very important. You have to use the term called aware of the connections. That's it. If you use that word, okay, you need not explain in detail what it is. A stateful firewall is aware of the connections that pass through it. So how is it aware? It adds the information and maintains this information about the connections in the table called as what table? State table. It maintains this information in a table called as a state table, or sometimes it is also called as a connection table. It is also called as connection table. So my firewall is going to use this connection table as a reference. Let's say you are trying to implement some security policy. What is your security policy saying? Your policy is saying that don't allow any traffic towards YouTube. So if a connection is made towards a YouTube, then immediately it will look at the connection table. Okay, fine, there is an attempt to make a connection, so it is denied according to the security policy, so that traffic will be removed. Okay, so what is meaning of stateless then? There is one more firewall called stateless also. So stateful firewall will remember the connections. So what do you think stateless firewalls will do? A stateless firewalls are simply doing packet filtering. They are doing packet filtering. Okay, they do not monitor any type of connections. They do not remember any type of connections. So usually a good example is our router. Okay, a plain router. It does nothing. It does not remember the TCP sessions or the UDP sessions, whatever you make. So it does not matter for the router if the connection is coming from outside to inside or inside to outside. So these are called as the stateless firewalls, which is not at all recommended when you are connecting to an untrusted network. So up to here, I think this is clear. Next, one more fundamental thing you have to understand is what information is maintained in the stateful firewall. What information is maintained in the stateful firewall? So information in stateful firewall. Pardon me my writing here, I am just scribbling. So the most important information you will remember is who has sent the traffic at layer 3. So layer 3 information is the source IP address. Okay, and then what else do you have in the layer 3? You also have to whom the traffic is sent to, that is the destination IP address. So these two are layer 3 information. L3 information it will remember, and then it will also remember the protocol information. What is the protocol information? Whether the traffic is for TCP, is it TCP based traffic or UDP based traffic. So which layer is this? Again layer 4, L4. Okay, and then the port numbers, So what is the source port number? Again, what is the destination port number? So port numbers it will remember. So all this is layer 4 information. Okay, so including whether it is a SYN flag or you remember the TCP flags, SYN, ACK, FIN, push, URG, all those flags it will remember. So here these are the layer 3 and layer 4 information which your stateful firewall would actually remember. I hope this is clear. Okay, let's move on to the next part here. Let's say how can we allow the packets from, do you remember the security levels? Yeah, so if you remember, every firewall will have multiple interfaces, and every interface, depending upon which network it is connected to, is given one security level. So for example, for ASA firewall, if it is connected to the internet, that is WAN, the security level will be 0. That is completely untrusted network. If the connection is towards a LAN, then the security level will be 100. And you can have multiple security levels assigned to different networks which you can assign internally. For example, if there is a Wi-Fi network, if Wi-Fi, someone is trying to send data to the internet or WAN, then you may assign the network number 50 security level. Or you have some network, okay, like a server you have installed in a DMZ, you want to send the traffic from the server towards the WAN, or you want to allow connections from WAN to DMZ, maybe you will give it a level of 70. So these are called different type of security levels. Now the question is, how do we transmit data from LAN to this, that is lower, that is from higher security level to lower security level, or from lower security level to higher security level. Now from higher security level to lower security level, it is allowed by default. Always by default the traffic is allowed from high security level to low security level, it is allowed. But by default it is denied. Denying what? That is, any traffic coming from low security level directly to the high security level is denied by default. So how can we allow this? The question is, how can we allow, if we have to allow a traffic coming from a lower security level to the higher security level? So this we have to use something called as ACL, access control list. Access control list. So when we are using access control list, we are not allowing everything end to end. So we are basically controlling the flow of traffic. Let's say for example, you want to allow only one server access. Okay, you want to allow only one server traffic towards the LAN for some reason. Okay, maybe you are monitoring this server from a some server is there, monitoring server like SNMP server is there. You are trying to monitor the health of this particular server, so that data related to that particular alert should come into your LAN. Then for SNMP reasons or monitoring reasons, you want to allow only that traffic. So you will use an ACL to allow that traffic only. I hope that is clear. Okay, so what is DMZ? What is full form of DMZ? I was talking about DMZ here. What is full form of DMZ? Demilitarized zone. Demilitarized zone. Here, what is this demilitarized? I comes here, E comes here. Sorry about the spelling here. Demilitarized zone. I think this one is correct. Okay, so this is the network which some of these machines you want to allow connections, or you want to accept the connections from the untrusted network. So why are we putting these servers on a separate network? See, if it was not a separate network, then you would have to allow the connections from untrusted networks like WAN directly to your production networks. You don't want to allow a direct connection from outside to your production environment. So what will you do? You will keep a separate network for these servers, and you would only allow the traffic towards this network. So what is needed? So let us say you are allowing a particular contractor employee to work on particular server, or if there is a third party company or a business partner whom you want to allow access on these servers. so that you can do it using a DMZ network. Okay, so usually servers like web server or FTP, let us say your third party vendor want to dump some files. Okay, you can give a server here FTP service allowed, and then you can leave that open here. Then he can directly dump to this FTP server any data which he want to give it to you. Okay, so this is the basics or very fundamentals what we have learnt previously. So let's continue. We have also learned some terms here. If you remember, there are some terms called ingress and egress. What is ingress? Ingress, any idea? Is it inside traffic or outside traffic, or inside interface or outside interface? Ingress, as the name suggests, it is inside interface. That is the interface which is connecting. That is the interface which is connecting to your LAN. Egress is outside. So this one is representing the WAN connection or WAN interface. So that's ingress and then egress. So how does a firewall process a packet? So as soon as the packet would come, how would a firewall will process? So when a packet is received on the ingress interface, when the IP packet is received on the ingress interface, the firewall will check if it matches an existing entry in the connection table. That means I told you, right, there will be a connection table, okay, that it maintains all the layer 3 and layer 4 information. So as soon as the packet would arrive, immediately my firewall will check if there is any existing connections in the connection table. Maybe my firewall is thinking that this packet could be part of a existing connection, or maybe this is a new connection. So if it is part of an existing connection, then a protocol inspection is carried out on the packet. What is a protocol inspection? Whether this packet is allowed to be sent out or not. So if it does not match any existing connection, let us say if there is a new connection, then either a TCP SYN packet or a UDP packet is again subjected to ACL checks. That means it will go through the third step, which is called as an ACL checks, if it is a new connection. If it is an existing connection, then it may not go through the ACL checks, because already this step might have been covered previously. If it is a new connection, then it will go through the ACL checks. Okay, so why is ACL checks? Because in the ACL checks, we will be checking at layer 3 addresses and layer 4 ports. Both these things, they have to match. So why a new connection? Because how will a firewall identify a new connection? Usually the new connection will be TCP SYN. A new connection will be a TCP SYN connection. That is how a firewall would identify that. Okay, so if it is any other connection other than TCP SYN, maybe my firewall will not check this, and it is going to check an existing connection in the connection table. Only if it is TCP SYN, this will subject it to ACL checks here. Okay, so yeah, now sometimes hackers would actually send out, instead of a TCP SYN connection, they just wanted to make sure that if there is a real machine inside or not, whether it is allowed connection or not. So a malware which is infecting some machine inside your LAN, okay, it will try to send out messages, okay, using all the TCP flags. So sometimes they will be sending out a TCP SYN or TCP FIN, or randomly they will try out all this so that they can fool your firewall or fool your ACL to make a connection from inside to outside. Okay, so when we are writing an ACL, we have to be very careful to check all these things. Okay, so now comes here. All right, so if at all there is a TCP existing connection, how much time does a firewall remember the TCP session? How much time does it maintain the TCP session? Let us say you have sent, if you remember, TCP session, a three-way handshake process, SYN, SYNAC and ACK, and then there is also FINAC, and then again one more FIN coming from the other side. So when the TCP session, if you are closing the TCP session, then the machine which want to close the connection will send a FIN message, and immediately he will get a FIN ACK. He is going to send, sorry, not a FIN ACK actually, an ACK message for the previous FIN from the receiver. Now receiver will later on send from his end a FIN. So there is a time gap between this acknowledgement and a FIN the FIN message coming from the let us say this is the server and this is the client. Okay, so this time gap is limited again. So this is my timeout. If for some reason my server is stuck, so during this timeout, my client will have to keep that session open. The TCP session should still be active, or it has to be open. Okay, so whenever you are sending a FIN, immediately this state will be moving to close wait session. Okay, and you will still wait for the second FIN message or the FIN message coming from the server. Till then this is in the state called as close wait state. So you will see this in your own computer when you type netstat-na in a Windows computer, netstat-na, you will find all these states in the last column. Alright, so how much time will the client wait? What is the time interval? So for TCP sessions, the time interval will be for 60 minutes. For UDP sessions, the time interval will be for 2 minutes, and for the ICMP session, remember ICMP for ping replies, it will be for 2 seconds. So this time interval varies. Okay, so yeah, I hope this is clear. Now let us try to go and configure a firewall and see how it works. Alright, so for a moment I am going to bring out my own packet tracer. The packet tracer which I am using will be 7.2 packet tracer. This is the packet tracer I am also expecting you to use. So as I told you earlier, this requires a login to the netacad.com website. Without internet, this packet tracer would not work. Okay, just a moment. Yeah, so I got a packet tracer. Now we are going to design a network from the scratch, and we will install a firewall. So I am going to select here 5506 ASA firewall here. Now this firewall has got gigabit interface, 8 gigabit interface, 1 management interface, and already gigabit 1 by 1 is pre-configured with an IP address 192.168.1.1, the default net mask value. Next, I am going to connect this gigabit one by one, that is a LAN interface, towards my LAN switch here. I'll add some PCs, the end devices, 2 should be enough. Okay, so if you remember, this network is 192.168.1.0 network, and this is my LAN network. So I haven't connected a WAN. Now let me label this. Okay. Now usually we would make a connection to the service provider network. So let's call this router as the service provider router, ISP. And now I am going to make a connection. Okay, I think the cable should be a cross cable, not a gigabit cable in this lab. Yeah, and service provider. Okay, to represent some hosting website or hosting, I'll just say this one is some external router which is hosting some server. We want to access some web page there. So I'll deploy a server and a switch. Now this is representing an external network. Now I am going to connect this. And let's call this network as we'll give some public IP address to this. If you want, you can even give a private IP address and then perform an adding on this one. That's up to you. That will be an extra step. So I'll give public IP address, private IP address here. We will perform an adding while the traffic is going out, and 172.16.0.100/24. I'm going to label this server in that way. Now let's make a connection between the service provider network and the external router. Again, the cross cable. That's it. Now how many networks do we have? So we have 2 private networks here on both sides. Okay, and then we have a link from my firewall to the service provider, and service provider again, external router is also connecting here. That means we have 2 additional networks, which is a public network. So they need public IP addresses. So let me label them ahead.